Hello viewers, today we are going to see couple or torque. A couple produces rotation without translation. So first we will consider a light that is of negligible mass rod AB as shown in figure 720A. At the two ends A and B, of which two parallel forces both equal in magnitude and acting along same direction are applied perpendicular to the rod. So the rod is like this, the force is acting perpendicular, this is 90 degree and both the forces are parallel. Let C be the midpoint of AB. So C is the midpoint of AB. So CA is A and CB is also A. The moment of the forces at A and B will both be equal in magnitude because the distance is same and the force is also same. So therefore the moment of forces at A and B will both be equal in magnitude but opposite in sense as shown. The net moment on the rod will be 0. The system will be in rotational equilibrium, but it will not be in translational equilibrium. That is, sigma F is not equal to 0. Now we are going to see another case. Here both the forces are parallel, magnitude same, distance is same, everything is same. Now we are going to see the second case where the force at B in 720A is reversed in figure 720B. So now if you see, the force at B is reversed. So this force is acting at point A, it is downwards, here it is upwards. Even though they are parallel, but the direction is opposite. Thus, we have the same rod with two forces of equal magnitude. Both the forces have the same magnitude, but acting in opposite directions, applied perpendicular to the rod, one at end A and the other at end B. Here the moments of both the forces are equal, but they are not opposite. They act in the same sense and cause anti-clockwise rotation of the rod. See, now this force is acting this way and this is acting opposite. The force, the distance, everything is same. So it starts rotating. They are opposite and starts rotating and cause anti-clockwise rotation of the rod. So the rod will rotate anti-clockwise. The total force on the body is 0. So the body is in translational equilibrium. Previous case, the total force is not 0. Here the total force is 0. So the body is in translational equilibrium, but it is not in rotational equilibrium because it will start rotating. Although the rod is not fixed in any way, it undergoes pure rotation, that is rotation without translation. So a pair of forces of equal magnitude but acting in opposite direction with different lines of action is known as a couple or torque. A couple produces rotation without translation. When we open the lid of a bottle, by turning it, our fingers are applying a couple to the lid. So figure 721A. So this is the diagram. We tried to open the bottle cap. Our fingers apply a couple to turn the lid, anti-clockwise to turn the lid. Couple or torque. So when we open the lid of a bottle by turning it, our fingers are applying a couple to the lid. Another known example is a compass needle in the Earth's magnetic field as shown in figure 721b. So this is the figure 721b, you have north pole, south pole, magnetic compass. The direction of force will be in this direction, and then even though both the forces are opposite, they are parallel, but the direction is opposite. The Earth's magnetic field exerts equal and opposite forces on the poles of a compass needle. These two forces form a couple. So, another known example is a compass needle in the Earth's magnetic field as shown in figure 721b. The Earth's magnetic field exerts equal forces on the north and south poles. The force on the north pole is towards the north, and the force of the south pole is towards the south, except when the needle points in the north-south direction. The two forces do not have the same line of action. Thus, there is a couple acting on the needle due to Earth's magnetic field. So in this topic, we have seen three conditions. Two pair of forces parallel, distance is same. In this case, sigma f is not equal to 0. And then we have seen the second case where the forces are parallel but opposite direction, so it produces a couple or torque. And this type of application of force, we call it as couple or torque, and this principle is used both for opening out a cap in a bottle, and same thing applies for the magnetic compass also, this compass also. But there is one small difference. When both the north pole and south pole are in opposite, the force on the north pole is towards the north, and the force of the south pole is towards the south, except when the needle points in the north-south direction. The two forces do not have the same line of action. This is the point you have to remember when both are in the straight line. Thus, there is a couple acting on the needle due to the Earth's magnetic field. So, in this topic, we have seen about what is a couple or a torque, how the rotational forces happens, and we have just started with considering a small rod, application of two forces in parallel in the same direction and the two forces in the opposite direction. And what happens when we open a bottle cap, or another example is the magnetic compass needle. So these two undergoes a rotational motion which is called as couple or torque. That's all about this topic. Hope you have understood the basic idea of torque produced with certain examples. Thanks for watching. Nandri.